Our topic today is about Dockers and containers. We'll introduce Dockers and the containerization concept, along with their benefits, the differences between Dockers and virtual machines, along with the use cases for both. Last but not least, we'll shed the light on some challenges and security concepts. Dockers and containerizations are two of the most popular technologies in the world of software development today. They have revolutionized the way developers build, test, and deploy their applications. At their core, Dockers are a type of virtualization technology that allow developers to package an application and its dependencies in a single unit called container. This container can then be run on any machine with the same operating system kernel, making it highly portable and easy to deploy. One of the biggest benefits of using Dockers and containerization is the ability to create consistent environments across different machines. With traditional methods, it can be difficult to ensure that all machines have the same dependencies and configurations, leading to compatibility issues and bugs. In addition, Dockers and containerization make it easy to scale applications up or down depending on demand. By simply spinning up more containers, developers can quickly increase capacity without having to worry about setting up new servers or infrastructure. So what's the difference between a Docker and a virtual machine? While Dockers and VMs both provide a way to isolate applications from their underlying hardware, there are some key differences between the two technologies. VMs typically require a full operating system to be installed on each virtual machine, which can lead to significant overhead and resource usage. In contrast, Dockers share the same operating system kernel as the host machine, making them much more lightweight and efficient. This allows for faster startup times and lower resource usage while still providing isolation and some security. Dockers and containerization are mainly used in a wide variety of industries and applications, from web development to scientific research. One common use case is deploying microservices, where each service is packaged into its own container and can be scaled independently. Another use case is building and testing applications in a consistent environment, which can help identify bugs and ensure compatibility across different platforms. Finally, Dockers and containers are also commonly used in cloud computing environments, where they provide a lightweight and portable way to deploy and manage applications. We have some challenges and limitations, of course. While Dockers offer many benefits, there are some challenges and limitations to consider. One challenge is managing and orchestrating multiple containers, which can become complex and time-consuming as the number of containers grows. Additionally, some applications may not be well suited for containers, particularly those with complex dependencies or hardware requirements. Finally, security can be a concern when running multiple containers on the same machine, as a vulnerability in one container could potentially compromise the entire system. As the adoption of Dockers and containers continues to grow, we can expect to see continued innovation and improvement in these technologies. One area of focus is improving orchestration and management tools, making it easier to deploy and manage large number of containers. Another area of interest is integrating Dockers and containers with emerging technologies such as serverless computing and edge computing, enabling even greater flexibility and scalability. The future looks bright for Dockers and containers as they continue to transform the way we build, test, and deploy applications. Here are some security guidelines. Use Content Trust to check the digital signing of containers to prevent tampering and ensure authenticity. Use only trusted images from Docker Hub. You can as well limit container privileges and capabilities, as well as monitor containers' activity and implement network segmentation. Always check and update the Docker containers and images and follow the principle of least privilege.